Hello friends, Jim here with a report from a study that appears in the journal Nature Communications. And this has to deal with the Gulf Stream. Now you have seen me in other videos I have done talk about the issues with the Gulf Stream and how the Gulf Stream slowing down could lead to a certain other kind of climate issues, namely a cooling down. And I say that because we have data for it. We have data that shows when the Gulf Stream slows down or stops totally, a cold spell happens, ice age, what have you. And you have also heard me in all these reports that I have shared with you often lament that, well, I don't see enough studies addressing the issue of the Gulf Stream, of the AMOC, also, the Atlantic Meridional Overturn Circulation. And as to, we need to look more at that to see how that's going to affect climate. Finally, here's a study that looks just at that. And basically what the researchers are stating is that the slowdown in the Gulf Stream may bring later cold. And the Gulf Stream is weakening. We now have data that shows this. So therefore, Europe could expect some prolonged cold as the world warms. Okay. Now, the thing now is, as I mentioned before, is the issue of the thermal inertia. Is there enough heat in the system to forestall that, prevent it, or really further push it down the road? So let's get into the details here. As the Gulf Stream weakens, okay, in a rapidly warming world, northwestern Europe could paradoxically become colder, or at least cooler. But there is a time lag, and these two climate-related events, the time lag between that, U.S. scientists now think they know how long that lag could be, and they say it could be as much as 400 years. Now that's the lag. The actual shutdown in the conveyor belt could be on the order of decades, according to the work by the late Wally Broker. Okay. Now remember, the Gulf Stream brings warm water from the tropics to high latitudes, terminating in the Jin Sea, Greenland, Icelandic, Norwegian Sea, sometimes called the North Atlantic Drift at that point. But it terminates there. It gives off its heat, which is what keeps Europe, that section of Europe, Scandinavia, northwestern Europe, warmer than it should be for the latitude they are at. But as it gives off its heat, which is now warm, salty water, becomes cold and very salty, which now sinks. As it sinks, it's bringing that cold from the polar regions, subpolar region, back down to the tropic. Basically, it's a heat distribution mechanism for the planet. So how can we assess this? Well, we have the evidence of this happening before in the past. The world has warmed and cooled before. As the difference between tropics and Arctic narrows, there is a change in the conveyor belt, which is, of course, part of the climate machine. So the other thing that also is at play here is that there's also some other mixing going on when the Gulf Stream or the northward drift meets up with colder Arctic oceanic waters. So you're going to have some mixing event there. But the fact is, by giving off its heat, it has a higher salinity than Arctic oceanic water, so it will become more dense, and thus it sinks. And as it does so, it also, in sinking, is also a way to sequester carbon from the surface down to depth. And then it brings it, back down south. So, just to give you an idea of how much heat that is being transported by AMOC, a the chief scientific advisor in Britain once calculated that it delivers to the UK alone the equivalent of 27,000 power stations. That's a bit. Evidence from past climate history. Okay, we had the Little Ice Age, the Younger Dryas. I did a video some time ago. You can go check it out in my library of videos there about the Younger Dryas. So you can go and view that video if you care to. This has happened a number of times. 13,000 years ago is when the Younger Dryas began, and it lasted for about 2,000 years. And that made things a little cool for Europe. So new and sophisticated studies of fossil carbon show that anyone at the time, basically the Younger Dryas or the Little Ice Age, if there were scientists around, would have been able to observe any warning signs. Almost about 400 years before the abrupt shift to a cooler situation, the Atlantic current weakened, and then it started to strengthen again about 4 centuries before returning to warmer conditions. So any return of the ice ages takes place over decades and now with apparently several centuries of advance notice. This is the conclusion from this study. So let's go back, let's break this down. Happen over decades. That is referring to the shutting down of AMOC, but the several centuries of advance notice indicating when it shuts, when the AMOC shuts down, there's about a several century lag time before we start seeing the effects of said shutdown. That's kind of what they're getting at. Now, you can quibble on the timing and so forth, whether it's decades or centuries, but the mechanism is there. AMOC shuts down in a matter of decades. They used to think it was shut down over centuries, but now Wally Broker demonstrated over decades. But now there's enough lag that it could be centuries before the effects are felt. Now, if you throw in thermal inertia, it could be longer. This is what their modeling is suggesting. So, Dr. Francesco Muscitiello, who is of Lamont Doherty Earth Observatory at Columbia University. He's now at the University of Cambridge in the UK, but at the time he was at Lamont Doherty. He was the lead researcher. He states, our reconstructions indicate that there are clear climate precursors provided by the ocean state, like warning signs, so to speak. Now, he was at Lamont Doherty. Who did he work with? Oh, that's right. One Wally Broker. So, this is a recent report in Nature's Communication. Of course, it's in press for some time before acceptance for publication is finalized. And I can tell you without any doubt Wally Broker is in on this study. So climate scientists have clear dates for the timing of the Younger Dryas. Ice cores from the Arctic show both that Greenland's temperature fell by 5 degrees C or more at the beginning of the cycle, and that it rose by at least 8 degrees C at its end. So, basically establishing the timing of the onset and then the ending of it. To time the changes in the ocean current is a bit trickier. They use carbon dating techniques to identify a pattern of change in the marine sediments in the Norwegian Sea. Okay, let me explain more of the methodology, then we'll break it down. Since marine sediments settle very slowly over very long periods of time, they needed a more precise clock, if you will, to help calibrate their calculations. They found this in the fossilized ancient plants in the Scandinavian lake. Looking at carbon-14, Carbon-14 is pulled directly from the atmosphere each season by plants, foliage. It decays at a predictable rate, and the amount of surviving C14 delivers a reliable clock. The identification of 2 volcanic ash layers from eruptions in Iceland, in both lake and seabed, provided yet more confidence in the timings. From these factors, the researchers are able to identify a slowdown in the transport of carbon from the surface to the deep, and thus a slowdown in the current. There is also one other aspect they looked at, which is carbon-13. Recall in my lengthy isotopic fractionation video, I discussed, looking at the del C13, how that information can be used to assess deep water movement or deep water formation, or the movement of, sinking from the surface to depth, what we call ventilation. So we can look at the del C13 and tell when there was deep water formation or deep water movement taking place and when it was not. So if there's deep water formation taking place, there is vertical sinking, the conveyor belt is on. When there is not, the conveyor belt is off. We can look at the del C13 to ascertain that, and using C14 in the plants, use that as a further point of verification for our conclusions. Basically, further say, okay, yeah, there was deep water taking place, the conveyor belt was on, or the conveyor belt was not on. So they can look at that. And don't forget, looking, when in the ice cores, there are little trapped bubbles, and you can look at the levels of CO2 in those trapped bubbles to determine past temperatures. So there's a lot of information that can be found from ice cores and sediment cores. Basically looking at the isotopes. Wally Broecker is the pioneer in all of this. That's why he's called the grandfather of climate science. His contributions cannot be overstated. Stupendous. Amazing. So this research confirms the link between ocean circulation patterns and northern hemisphere climate shifts. It provides evidence what could be a considerable interval between the two. Researchers have repeatedly warned that the Atlantic currents seem to be slowing in response to what's happening in the planet, namely global warming due to human activities. And the consequences of continued slowdown could be very uncomfortable for hundreds of millions of folks in the centuries down the line. If the evidence from the Younger Dryas provides, Younger Dryas as an example, there's also the Little Ice Age and other events, provides a sure parallel to today's condition, then Europeans might have time to prepare. Dr. Muscitiello basically concludes saying, it is clear that there are some precursors in the ocean, so we should be watching the ocean. The mere fact that AMOC has been slowing down, that should be a concern based on what we have found. So, very interesting, and it's very, as I've been a long-time proponent of saying, look at AMOC to understand a major portion of the climate machine. It is personally gratifying to see this study and to see to see their work that they did and to see the results of their that they published. So now you can't say, well, it's only 4 centuries, so blah blah blah. Don't have to worry about it. Yeah, we do have to worry about it because planet Earth will be fine. It doesn't care if humans are on here or not. And after humans go extinct, Earth will still go around the sun for another 5 billion years or so, until the sun, expands outward, to the orbit of past Mars and so on. But in terms of humans, yeah, we're pretty much, basically going to end up causing our own extinction, to be quite blunt about it at this point. So, wanted to bring you that report, And thank you for your time. Hey friends, this is Jim reminding you to subscribe and share my videos. Also, don't forget to click the bell so that you know when I drop a video in. And I'm also asking for you to please support the work that I do by becoming a patron at patreon.com. Details in the description box below. Thank you for your continued support.